Welcome. In the last session, we have seen some impacts of climate change that are ocean warming and melting of ice. Now, in this session, we are going to see sea level rise. So, if you see what is the sea level rise, when the ocean got warmer and warmer, what will happen? It causes the thermal expansion. So, thermal expansion means the expanding a volume of water molecule. When a water molecule volume got expand, what will happen? The volume of ocean water will increase. Thereby, you can see sea level rise. So, this is the one reason when the ocean got warmer and ocean warming happened. So because of this ocean warming also, it causes melting of glacier or land ice. So thereby you can see the huge amount of the fresh water that is going to add in that is going to add as extra into the sea water, I mean sea water or oceans. So thereby you can see eventually a sea level rise because some of the extra water got added from the melting of glaciers and land ice, right? But not the sea ice, because sea ice itself ice within the ocean though. So when the sea ice got melted, it doesn't cause any much changes in the sea level rise or fall, right? Because the sea ice is itself in the ocean only. It doesn't add or remove some water from the sea itself. So if you see between 1901 and 2018, the old average sea level rose by almost 20 centimeters. So and moreover, thermal expansion or melting of glaciers or land ice not only causes sea level rise, but also some of other uh, components which also causes sea level rise, that is size and shape of the ocean basins, right? So if you see, to understand that, you have to know the two concepts called like relative sea level and absolute sea level. So if you see the what is the relative sea level is nothing but the changes in height of the ocean, whether it is rise or fall, relative to the land at a given location. For example, if you are at a coastal location nearby the land, which is near to the coast, and because of so-called human activities, so the pressure which is falling on that land continuously been increasing from time to time. So what will happen? Eventually, the land will go down, right? So thereby you can see the nearby sea level. You feel that sea level got raised, right? So because the land got down, so you feel that the sea level got rise. And similarly in the reverse case, when the pressure on that land has been uh, decreasing from time to time, so your land will go rise, then automatically you feel the sea level got down. So means rise or fall of the sea level with respect to the land. If you say, then that kind of sea level rise or fall, you can call it like a relative sea level. But in contrast, absolute sea level is nothing but the uh, changes in the height of the ocean level above the center of the earth, irrespective of whether the nearby land is rising or falling. So if you see from the above the center of the earth, if you see the height of the ocean, if it is changing either rising or falling, only if that change, if you measure or if you see that kind of changes in the sea level, either rise or fall, that kind of changes you can call it like a absolute sea level. In this case, you don't care about whether the nearby land is rising or falling like that, right? You have to only take care of the above the center of the earth, how much height the sea level, how much down on the sea level, like that. Okay. And if you see some of the statistics here I just mentioned, how the global mean sea level is rising from time to time, say for example 1993 as of now. From 1993 to December 2002, the rise was like 2.1 millimeter for a year. Similarly, from 2003 to 2012, it was 2.9 millimeter for a year. Similarly, from 2013 to 2021, it is 4.4 millimeter per year. If you compare from the first period, like that is 1993 to December 2002, it was at 2.1. If you compare current sea level rise, that is 4.4 millimeter per year. If you compare from the first period to last period, so it become around double, 2.1 and 4.4 millimeter years. You see, 2.1 is almost double to the 4.4 millimeter per year. Like that, this much, like this, the rapidly sea level has been rising from time to time, right? So according to some IPCC report, the worldwide sea level are expected to rise by 1.1 meters by 2100 if you continue these emissions like this. If you do not control, or if you continue like this, all these emissions are all, so definitely there would be a rise of 1.1 1 meters by 2100, right? Similarly, by 2050, 1 billion people. Some scientists are saying that 1 billion people living in the low-lying areas will be exposed to the coastal hazards because of the sea level rise and all. And you can see because of some projections, based on some projections of this greenhouse gas emission (RCP), representative concentration pathways. So various pathways how the sea level has been rising that you can see. So these are all some of the facts that are saying like sea level has been rising continuously. So what we have to do? So when the sea level got rise, so there will be lot of devastating effects like sea level rise inundates the low-lying wetlands, dry land, and erodes the shorelines, contributes to the and gives the coastal flooding and increase the flow of salt into the nearby histories or estuaries or groundwater. That what we call like groundwater aquifer. That what we call like saltwater intrusion, right? And not only and these effects but also cause some kind of coastal damage to the coastal infrastructure from the floods, and it also lost the tourism, recreation, transportation functions, everything. So these many impacts that we have because of the sea level rise. That's why we have to study well in manner regarding how the sea level has been rising and what to how to control it and how to face this all consequence in a well adaptation manner and all, right? And one more impact of the sea level rise is like 5 islands in the Solomon Islands have been lost due to the sea level rise and all, and coastal erosion, severe coastal erosion. So this was the first scientific evidence of the effect of climate change on coastline and people. See, and at this time, another 9 reef islands are severely eroded or likely to disappear in the coming years. So if you see if you see this image, you can understand that how sea level rise is going to affect direct effects and some coastal hazards. How you can see, and climate driven sea level rise and local sea level rise, and also non-climatic anthropogenic drivers of the climate change that cause sea level rise and all. You can see all in this figure. You can see what kind of coastal hazards that we can see that we can get because of the sea level rise, like submergence of land, enhanced flooding, erosion of land and beaches, salinization, I mean the saltwater intrusion, and loss and change in the marine and coastal ecosystem, right? So these many impacts that we have, and one more studies that saying anthropogenic subsidence that I told you in the last slide, going down of this land and all subsidence and sea level rise always threaten the many delta cities such as New Orleans, Kolkata, Yangon, Bangkok, Ho Chi Minh City, and Jakarta. These many coastal cities are going to be severely affected because of this anthropogenic subsidence and sea level rise, right? Because of when these all risk get because of this risk caused by the sea level rise, that you have these all cities have to face a lot of increasing threat from the floods or saltwater intrusion and all, right? And coming to the IPCC sixth assessment report, it was named that Mumbai is the second largest of the among 20 largest coastal cities to suffer major financial loss due to this floods and sea level rise after Gwangju in China. And one more, many reports told that sea level threat to the coastal megacities in India, especially Mumbai, Heron Point in Sundarban, Chennai, Cochin, right? So what we have to do like to control to respond to the sea level, what kind of mitigation strategies that we have to follow from both in all dimensions, right? So we have already some of the I mean some many international or national organizations have been set up some kind of mitigation strategies to protect or response to sea level rise. If you see this image from this illustration, you can understand how we have to respond to the sea level, like no response, advance, protection, retreat, accommodation, and ecosystem based adaptation. So this is on kind of the response to the sea level, how to protect the in which manner we have to protect our belongings or things near the coast when the sea level got rise. I mean, while fighting against the sea level rise, right? And ecosystem based adaptation is a one which includes the restoration of all salt marshes, mangroves, oyster beds, or coral reefs and all. Because these all coastal ecosystems mitigate the marine flooding and coastal erosion. So we have to protect all these we have to enhance these ecosystem based adaptation methodologies while protecting these all salt marshes, mangroves and all, right? Because this will reduce the risk for people living in the coastal areas as well, right? If you see, this is a ecosystem based adaptation. So impact, the first will it reach the this ecosystem based, thereby we can somehow protect, right? So and it is somehow in this no response, advanced protection, retreat, also accommodation in this type of response of sea level rise, also we use this ecosystem based adaptation. And some of the other practices that many countries followed, the hard production like constructing dikes, static seawalls and all, to response to the sea level rise and all. But this somehow, however, this has some another effects of the severe coastal erosion and damage to the marine habitats and all. And thereby you can see some kind of soft adaptation practices as well to face the sea level rise and all, and also to control the, I mean to to manage the beach, like a process of called like a beach nourishment and all. So in this hard protection, you can also see the another impact by protecting from these all while responding to the sea level rise. You can also get some another impacts of that sea level, shoreline erosion or marine habitat destruction and all. But to overcome this issue with some kind of strategies came, like adaptation methodologies came, that called like soft adaptation also. In this process, beach will be nourished. And this is one, I can say this is one of the environmentally friendly protection response for the coastal ecosystems and all. So if you see the entire picture, like a building hard production, soft production, implementing and designing of a new coastal models and accommodation to reduce the vulnerability. So if you see the entire map in a, such a four corners, like protection from the coastal hazards, adapt to the coastal hazards, integrated approach or infrastructure based approach. If you see all these dimensions, so that you we can understand like how we have to respond to the sea level rise, right? Okay.